Hello, this is my Module 8 Excel spreadsheet, and I was told to do B19. So here I have my descriptive statistics of State B in Iowa. So the mean of State B was 7.5, standard deviation was 1.3269, and then the max and minimum. And then for Iowa, the mean was 7.54, and the standard deviation was 1.3011. So as you can see, the standard deviation were super close in number, and same with the mean. It was about like 0.04 ounces off. And then for my two box plots, the blue is State B, and then the orange is Iowa. And we have a few outliers in State B and in Iowa as well. But here you can really see the mean where the X is and the dark black line is. You can see that they are close in number, just like I said up here, with 7.5 and 7.54. It's just a picture of the mean. And then for my null hypothesis, it was Iowa and State B have equal means. And then for my alternative hypothesis, it's Iowa has a higher mean than State B. And so I said that the null hypothesis was true because it differs by less than 1 ounce. And I chose to retain the hypothesis, but I'll get to that in more detail later. And then for the conditions and assumptions, this was a random sample, so independence is likely within the weights of these two sample sizes. And then I said it was a nearly normal distribution, and it's a homogeneous variance because the spread is similar since we are looking at birth weight. And then for my standard error, and I did the unpooled one, I got 0.0831, and how I got this is I took the square root of the standard deviation of State B and Iowa and squared that and divided by 500, and then I added those two together. And the equation, I think, is in our book, like chapter 17, I believe. And yeah, so I got 0.0831. And then from there, I got my t-score of 0.4813, and then my p-score, which I calculated on Excel, as 0.3167. And then I said that my results are consistent with Iowa, and the state that I said was State B is Minnesota, because they have equal or highly similar average weights for babies born in 1996. And then from there, I'll show you my distribution and confidence interval. So this is my distribution model. So my t-test statistic is 0.48. So I put the line right here, and then I shaded in since we were only supposed to do one tail end. And then for my confidence interval, I had it between negative 0.1743 and 0.243. And for my statement, I said we can be 99% confident that the difference in mean weight of the babies from the two populations are between negative 0.1743 and 0.243. And so I do believe that my sample came from Minnesota because the average weight in Minnesota was 7.5, and Iowa was 7.54, so it was a 0.04 ounce difference. And babies born in Iowa and Minnesota tend to be like the same average weight. And then I believe my test resulted in a correct decision, so I didn't do the type 1 or type 2 error. And then the zero, I forgot to mention the zero relating to the confidence interval. And we use that just because that's what the null hypothesis said to use. And to make sure I have everything, I'm going to check real quick. Yeah, so basically I came to a conclusion that Iowa and Minnesota have similar average birth weights because it's 0.04 difference and it's less than 1 ounce. So we can say that those are pretty similar in size. Thank you.